Right, okay, the first question. There were some really good things that came out of this. There was some good knowledge, but there was also some not reading the question very well and answering the wrong context in this one. Right, so this first question, the perfect answer is to say that paging is fixed size blocks of memory. All the blocks are the same, and that's what we split it into. Segmentation, variable. Okay, so there's two words, physical and logical. So segmentation is a logical view of the program and the data that you've got in memory. Paging is a physical view. Okay, you could say other things, and I did award marks for things that aren't on the mark scheme if they were true statements for that. I'm not gonna write on there. It takes longer to write than talk. So, but it's really important that you are describing a difference. Okay, so that was generally not too bad, that one. Right, now the next bit, if they're asking about running out of physical memory, they're asking you about virtual memory. Notice they haven't used the word virtual memory. They want you to say it, don't they? Okay, so if I was answering this question, what I would do is just say, right, well, a solution to this is virtual memory. It's 4 marks. So you've got to make 3 more statements. So explain what virtual memory is. It's space on a secondary storage device, which might be a hard drive or an SSD. Memory that's not currently being used, which may be pages or segments, I don't know, can be offloaded to the virtual memory to make space for programs that we are and the data that we are trying to process. Okay? If something in virtual memory is needed in the future, it can be reloaded and something else can be swapped out. You've got to get yourselves a nice 4 clear points for virtual memory. Okay, to just say it. As if you ever get asked for a definition of it, or how does it work. Okay. Right, the next 2 questions were quite interesting. The first one was, what is an interrupt? Your standard answer to this is it's a signal that a device or some software wants attention. That's what you should put. Some people went around the houses, I gave them a mark if it was okay. Some people sort of didn't use technical words. Try and use technical words. Signal is the key word. Okay. It's only a throwaway definition, so it's only 1 mark. Now, next bit. If you did not read this question correctly, like a few people did, you might have been talking about processors and tasks or programs, because you were talking about how does the operating system deal with an interrupt. We're lower down here. We're talking about the fetch execute cycle, the last step. Check the status register for interrupts. What happens if we get an interrupt? That's what they want to know. Okay? So it's really important that you're talking about CPU elements and not, a few people keep saying program and things like that. It's got nothing to do with programs. It's nothing to do with the scheduler. Yes, interrupts are used by the scheduler to stop the time slices, but that's not what they're asking us about. So the first step, if an interrupt has occurred, we're first of all going to say, right, the program that we're currently executing, the next instruction that we want to fetch is in the program counter. I do not want to lose that, so I'm going to save it. So we're going to push the PC onto the stack. Now, it was nice that some people made a bit of a hash of this, but they got some key elements on it and they picked up some marks. So if you said push PC onto stack, you were going to get something. Yes, I know, onto's 1 word. Because I'd turned around and I come back to it and I couldn't get my cursor in the same place. Right, I pushed the PC on the stack. That's my first thing. I then load the address of the interrupt handler. Now, we're not getting into the details of how we do that. That becomes architectural. how the CPU handles interrupts, and it's different on lots of different CPUs. We can load the address of the interrupt handler and put it in the PC, which is why we had to save the PC. Right, we can then just start the fetch execute cycle, because all that the fetch execute cycle does is grab something from whatever's in the PC. So we'll execute. So we can start our fetch X, and theoretically what should be happening now is the interrupt handler runs. So when the interrupt handler is finished, it has to let the CPU know. Normally by saying return from interrupt or some such instruction. We can restore PC from stack, and that will be a pop operation, and then we can start a new fetch execute cycle, and we carry on as if nothing ever happened. A few people said that we will be in the middle of an instruction. No, no, no. Instructions are atomic. You don't check for interrupts until we've finished executing. That's the key bit with the fetch execute cycle and handles interrupts. Okay, so please never say that. It's always after an instruction is executed, we do a check. Because we know that the state of the PC is fine. Other things you could have said is that it's the responsibility of the interrupt handler to save any other registers that it's going to use. The reason we do that is because you would be needlessly saving registers if every time an interrupt occurred, and that would take time. So we don't do that. It's the responsibility of the interrupt handler. Which is why if someone writes a really bad interrupt handler, they can tank a computer. And you get blue screen of death on Windows. Okay? It's really important that you read the question. That was about CPU stuff. I think that was the end of that question, so I'll stop moving.